Thank you all for coming. Very glad that we had such turnout for the first ZK Dive in New York City. This panel is going to be the final event of the evening. Just going to run through who everyone is first, and then we can start. Any questions that people have, feel free to jump in as well. I'm Geffen. I worked at Iron Mill and currently I'm just doing this, but I've been in love with your knowledge for a year and a half about.
Lurk, and I work on E3 and Polygon 0.
I'm Matej. I work at Lurk Lab. I'm just kind of like a general cryptographer. I'm relatively new to ZK, but I'm like absorbing it as fast as I can.
My name is Luke. I'm co-founder and CTO at Puzzle, and we're working on infrastructure and wallet on Helium.
I'm Jim. I'm the CTO and co-founder of Irreducible, and we're building the fastest proof generation clusters for web computing.
Very nice, very nice. So I wanted to prompt first, it seems like zero knowledge happens a little bit in seasons, with virtual machines being very popular a year and a half ago, and now proof markets being much more popular. Why do you think this might be the case now, and what do you think the effect of this is going to be?
Sorry, the question was both, or why are proof marketplaces becoming?
Yeah, why do you think this is something that companies are investigating now?
I think basically there's three factors that have unlocked modern ZK. So one is recursion being practical and efficient. Two is lookup arguments, which have really given a big performance boost to a lot of things. And the third is ZK VMs being practical. And essentially these have all led up to performance improvements, but ZK VMs in particular also lead to a huge developer usability improvement. And I think that's the crux of it, that we just, especially with zero knowledge VMs, it's a lot easier to use zero knowledge because you don't need to worry about your finite field and whether it's going to overflow and so on. So I think that's my answer.
Any other thoughts?
I mean, this might be a hot take, but I think
Love it. I'm here for it.
I don't know if proof of marketplaces really make sense. I think the future of ZK is on device proving. I think we're just getting a lot better with our proof systems, and they're getting a lot more efficient, where we're not going to need to farm out our computations to some big AWS machine somewhere in the cloud. I think the future is going to be you click a button and it just runs in your browser. I think we're far away from that, so maybe proof marketplaces are kind of a stopgap between now and that eventual future. But I don't think that's the future of ZK necessarily.
I would kind of agree. I think I see prover markets or marketplaces as more of just SaaS. It's just you pay them and they do your proofs for you. I don't really know how much of a marketplace it is, but I mean, at least for us on Alio, we built our own delegated proving system because we tried on-device proving and it's not feasible yet, mainly because of the proving verifying key sizes being gigabytes, which no one really wants to wait around and download for, and then especially if we're trying to build technology for people in developing places around the world, that's their entire data plan, maybe, or way over, or that would just take way too long. And especially if you have different keys for different functions and you're trying to do many different things on the blockchain, that's hundreds of gigabytes worth of storage space that you need to have in order to have on-device proving. So I don't know. I think a lot of the prover marketplaces are really also kind of just something for venture capital to throw money at. To be honest, yeah.
Could someone explain prover marketplaces in 30 seconds, real quickly?
I honestly don't even know if I could.
Okay.
I don't know why. I don't know why they exist right now, to be honest.
I just have no idea what that is.
So I have some computation that I want to generate a proof for, and I send that to some node that's going to handle that, and it might to a number of provers competing to generate that for me, but eventually the result is that I get it back and I have it, and this is good in cases where I don't have the computation to be able to generate that proof myself.
Okay.
You're throwing away the privacy. You're just paying someone to prove it for you. It's too expensive.
Well, yeah, that's their privacy is spectrum.
Yeah.
Okay, well that was not the hot take that I was expecting out of this guy. How do you feel like hardware, research going into hardware factors into proof markets versus on-device proving?
Yeah, I'll answer, or give an answer. Proving is getting cheaper, but it's still I don't know, hundreds of thousands times more expensive than native computation, and there's definitely some floor to this. You're doing lots of work per, amount of work that you would need to do to natively verify a computation. So, yeah, I deeply believe that if this is valuable, there is going to be demand for the most efficient hardware that's going to do it, and I don't think that's CPUs or GPUs, and that's just sort of been borne out by other industries and technology that have had specialized compute tasks with a lot of demand, and the efficiencies that you can get from having either application-specific circuits or application-specific instruction set processors. So, our approach at Irreducible was to start with that premise that we will end up with highly specialized hardware for ZK, and then ask what proving algorithms are going to be most compatible with that, and basically that led us to invent a proof system that's pretty different from what other people were trying to do before.
To dig a little deeper, is there a time frame that you're aiming for? Because this is kind of a back and forth with proof systems, getting better at conventional hardware, getting better at a variety of hardware, versus forming hardware that supports these existing proof systems. How do you decide where the target is for you?
The target in terms of timeline?
Yeah, I guess.
As soon as possible, because the space is moving fast, and that's sort of motivated our decision to use FPGAs as the primary piece of hardware that we're developing for. If people don't know what these are specialized devices that you don't need to make a custom circuit. You can just buy an FPGA from a vendor, and you can configure it to run a particular circuit. So it's sort of lower level than a CPU or GPU in that it's actually emulating or executing native digital logic, but you don't need to go and make a circuit, which means that our time for development is definitely longer than software. It's harder to develop digital logic, but it's way, way faster than writing basically timeline-wise, we think that we will be able to prove interesting statements with Binius, with FPGAs by the end of this year, and then it would be a few years out until there was any sort of pacing for this.
Yeah. I'm curious. The way it appears to me is that for a while we've had an innovator's dilemma that people were scared to take a particular proof system and make it really, really, really good, because by the time it takes you a year to do that, and then a year later we have a way better proof system. But it's been a few years, and now we kind of have protocols that are good enough to do things like RISC-V, or real ISAs, a stable target basically, and now we can start dumping a lot of capital into that. And so that's kind of how I see it, but it also implies that the proving system itself is more fungible. They care less about the proving system and more about just that I can run my programs on it. But I don't know if that's true. I'm curious if you think that's true.
Yeah, I think that end developers are, for the most part, just going to write some program in a language or sort of some architecture specification that's fairly detached from the underlying proof system. But I still think that there will be open source projects that are just more mature because there's more broad effort going into it from a lot of participants, and it achieves a level of stability and performance that makes it sort of stand out from the rest to the point where it's not going to like, I don't think we're still gonna be in this sort of situation where there's like, I don't know, 8 different proof systems that like a reasonable person might go and try to implement if they were doing like a ZK project from scratch.
Because I feel like if you want to upgrade before, you need a really complicated upgrade. Like look at the Zcash upgrades where you have to have all this backward compatibility. I mean, I guess they don't really do backward compatibility, they just have turnstiles. But maybe if you're just running with 5, like it's a lot easier to just recursively verify the whole proof system, and so maybe you can just swap it out whenever you want.
Sure, I agree that like basically compatibility from a developer point of view shouldn't be that bad if you just have multiple proof systems sort of targeting the same specification. But I'm still saying there's a ton of work that goes into developing any proof system, and for one to hit, you know, a level of security and trustworthiness and sort of the feature set and the performance level and the architecture support that people expect. I just don't think we're going to have like many projects that are at that caliber where someone would actually want to switch between.
Yeah, I agree. I just mean like if there's a new lookup argument, you can like tweak one number to make it better. In the past, like you couldn't really tweak a tiny piece, but maybe now you can tweak a little piece. Like we can have more like rolling upwards.
Yeah, I think that seems right. Like we're definitely like proof systems are way more of a weird composition of a lot of different techniques than anything that like you would go and read one paper and go and be able to implement it. So I definitely buy the idea or like believe that we're gonna have proof systems that are sort of evolving with new research.
I mean, I think like this is just also like an extension of the modularity that's been happening over the course of the last few years. So I'm like new to ZK, so my learning experience was really interesting because when I started learning about snarks, the first thing everyone that was telling me is like, oh, it's like a polynomial commitment scheme together with some IOP. And I'm like, okay, cool. But then you, like just 1 year before that, if I had started learning 1 year before that, it would have been some complicated mess of the polynomial scheme and the IOP being melded together, and no one was really making that separation. So like I think over time we're like making things more modularized, and so like ZK VMs are like a great example of that, where now we're saying like, okay, this is our polynomial commitment scheme, this is our IOP, this is our lookup argument, like, you know, this is our hardware that we're going to prove everything on. Like I think at some point when everything is, when we really understand like how everything is modular, how we can glue things together and retain security and you know, compose all the different pieces, then I think like it'll just be as easy, like you said, just swapping out one component for another, and we'll be able to like upgrade our proof systems, just like, you know, we upgrade like hardware and computer or whatever.
Plug and play.
Yeah, like plug and play. Yeah, and like the proofs will, you know, will be verifiable like by whoever, you know, wants to verify them, because we'll have like versioning, and the verifier will have like all the protocols that have almost in some sense have ever existed in their repertoire that they can verify they have to.
I mean, to like, I guess one point to make, you're working on Plunky 3, which is a really like general framework for building proofs of a particular type, which is like Starks. And you know, you guys have done amazing work sort of making that general over a bunch of configurations, but like our experience building Phineas, we started by like actually trying to use Plunky 3 to the maximal extent, and like when you get into a realm of like really different cryptography, it's just really hard to fit that into an existing framework, both from an engineering side and from the math side. Like some of the lookup arguments that work for prime fields like don't work for binary fields, or at least you need adaptations, and vice versa. And so there's always like, I don't know, some limit to like what is composable with whatever else.
I and many other in the industry are blessed with this. It's a fantastic of encoding all of abstract algebra into the Rust type system. I think it's actually interesting to look at things like PyTorch or like
Louis Torres, like, they also have a very well, I mean, their algebra is even simpler than ours. It's just multiplying matrices, and yet they end up doing everything in a dynamic language. Not by happenstance, but actually because it's better, because you just like do it dynamically and figure out at the end what you actually want to do.
Any audience questions? Or I could ask a question. This is maybe a little bit in a different direction. It feels like in this field, a lot of work is out in the open. There's a lot of open source stuff, work papers, etc. But you also see a number of people try out different versions of the same thing, and there's like sort of a lack of cohesion of what direction things are going in. Do you feel that there's any opportunity to better coordinate around like where we think it's worth putting energy in versus not? This is maybe a meta question. Or I guess alternatively, do you feel like you have clarity around what requires the most energy, what is the most pressing in ZK to work on right now?
Let's see. I think one thing that I definitely feel is like there's a bit of a performance race between a bunch of projects, and I'm not sure that's the most constructive thing, and like internally in our roadmaps, we've had to do a lot of reflection on like how much time are we going to put into like performance tuning for these specific cases to like meet the benchmarks, or should we just be like focusing on feature development and also security of these systems? Like there's a whole bunch of considerations of at the end of the day, you'd rather have a proof system that's secure than one that's fast and not secure, because then there's no point in doing that. So I do think that even though performance is sort of one of the big bottlenecks to adoption, I'm not sure the current way that the industry is going about solving performance and the benchmark battles is the most productive right now.
Yeah, I mean, I personally, I am more on the high level product side of things and implementation of production stacks and consumer software than I am low level cryptography or mathematics. So this may be a biased take, but I feel like the industry is not doing enough work on the product side of things, and performance race, or just who was the first ZK-VM, or
Who's the fastest CKV?
yeah, just okay, you might be the fastest, or we all might be trying to get the best proving system out the door, but why? Where's the products? If we built the coolest shit in the world, who's there to use it? Where's the demand? Is the pitch good enough? Because it's really just for scalability and privacy, right, of blockchains and some other things. But do people even care about that? That's where my concern in the future is we build all this crazy shit and no one wants to use it. And I don't know. That's just my concern.
Well, this makes me kind of curious in the product direction. I just have this impression that whenever we're thinking of what product to make, we throw a hackathon and we ask random hackers this question.
Yeah.
And how much do you think that companies internally even try to grapple with it, or are they just kind of focused on optimizations and papers, etc.? And if that's the case, then why is it just that we're asking the hackers the questions of where's the product?
Yeah, I mean, I don't think this is a zero knowledge problem. I think this is a crypto problem, cryptocurrency, blockchain problem in general. I think crypto's got a PR problem, and we need to fix that, and we need to show the world how it can be changed and deal with regulation and governments and authoritarianism. And I think all of this zero knowledge stuff is just contained underneath that. It's a very deep world and an incredible world, but it just rolls up to it's just crypto's problem at the end of the day still.
Do you feel like it suffers from that? And is there some creative way out from that?
Yeah, I mean, obviously zero knowledge doesn't have to be used in blockchain and cryptocurrencies, but I think that's kind of the problem.
cool math.
Fair enough.
But, yeah.
Um, Why do you think like ZK rollups haven't taken off like compared to optimistic rollups, even though we have like Polygon ZK EVM and ZK Sync as well, right? They're live. Why haven't they taken off? Just curious to know.
Anyone want to say?
I don't know. Yeah, the definition of taking off is personal, but we started out building on Aztec Connect, which was like Aztec's version 2, their rollup, which offered for the first time like on-chain programmable privacy. And unfortunately, they shut it down early so they could kind of focus on Aztec version 3, which is now just known as Aztec, which should hopefully be in testnet later this year. But hindsight's, well, we'll never really know, but we were seeing a lot of like promise with Aztec Connect, even though it had limited functionality. So I would have hoped that Aztec Connect would have taken off if they had kept it running.
What do you mean by limited functionality? That you can't build like you can't use the very complex EVM app and bridge it like.
Yeah, I mean you could bridge into it and like shield your funds, and then they had these things called bridge contracts, which basically you could like write a bridge contract for a particular DeFi protocol or something on Ethereum 01, and from within Aztec Connect you could interact with this bridge contract and actually perform DeFi operations privately. It was, the shielded set kind of gets smaller, or it's basically just contained to that one bridge contract. But yeah, it was basically like, hypothetically the entirety of the Ethereum ecosystem was accessible, but it wasn't just an immediate like plug-in and you could do anything. It's actually like you had to write basically adapters for every single contract you wanted to interact with.
You mentioned two use cases, scalability and privacy. And like the scalability aspect is pretty clear, but the privacy aspect, like I'm assuming Aztec Connect was ZK money.
Yeah.
But like we've had Zcash, and like when people think of privacy, they think of like Zcash or Monero. But then like the market is kind of like thrown those aside a little bit because of like regulatory government concerns. And my question is like, we're building all this cool tech, but like, do people care about privacy? And so that's where I'm like unclear of what those products would look like.
Yeah, I mean, I think Zcash and Monero were limited in that they weren't really programmable. So it's just like private Bitcoin. I mean, you could maybe do a little scripting, but it's not, the expressivity of the programming you could do is not nearly as broad as like Ethereum, where you could write just like general purpose contracts or anything. But to your question around do people care about privacy is a very interesting question, because like we found that they don't really care that much. It's kind of just like a nice to have. I mean, some people do, and like some people are like very hardcore tinfoil hat, like libertarians, and they'll do anything to protect their online privacy and their on-chain privacy if they can. But the general user, we found, really just cares about like earning, and privacy is kind of a nice add-on, I guess. But there are very interesting things you can do with privacy on chain, and actually like papers have shown that the market mechanics and efficiency of on-chain markets are actually improved with zero knowledge, because you can kind of obscure some of the pricing mechanisms. And, I don't know. I didn't fully comprehend the paper, to be honest, but
So like Aztec 3 is an example that's programmable in privacy, and it's supposed to be doing scalability as well, because it's settling back to Ethereum, right?
correct.
And I guess like that's where we could potentially see some of those use cases. Sorry, that question wasn't clear, but I'm just trying to like better comprehend where that could be going.
I tend to think of it like people won't pay for privacy, but when you have privacy, you unlock some like secondary things that are worth people spending money on. So like that you can use biometrics, or that you can have like find where money is actually flowing and like the interest in privacy is there, and then try to make use of that.
I also think, yeah, privacy, security is tricky. I think most consumers either don't care about it or don't care about it enough to like sacrifice it for other features. But I do think like businesses and institutions and corporations care a lot about privacy and security, and there's, yeah, if you want to see sort of institutional adoption, like actual financial institutions start to use this infrastructure, they're going to demand privacy to their transactions because that's what, you know, they're accustomed to.
I guess the pushback on that, like, yes, 100%, like institutions, like they're gonna need privacy, but also they move so slow. Like they're like, the boomer mind is just getting around like Ethereum being like okay. So
Well, Ethereum isn't okay, and that's sort of part of the argument.
well, not from a privacy perspective, but like, okay, like we're gonna allow this, we're gonna like quote unquote approve an ETF and that kind of thing. Like capital moves so slowly in the institutional world. So like, say Aztec is this great option that is scalable and private, like what he said, like is it still gonna take off for these institutions?
Yeah, I mean, I would say like also, you know, hopefully when crypto goes mainstream, privacy will also be necessary for the personal user. You know, like if you've done me money, you don't want me to go see everything you've done. So like, if we tell people that we built this beautiful system for them and they can come on and like have, you know, decentralized currency that no one controls, but if you send me money and know exactly everything you've done financially, then like no one's gonna want to do that. So I think it actually is kind of like one of the last pieces of like requirements for a hopeful mainstream adoption.
I think there's like a thing that has to happen though, which is something similar to like the move from like HTTP to HTTPS, where it needs to be like seamless for the end user, where they don't have to like click extra buttons and go through a bunch of extra effort. Like you want it to just be dead simple, because like your grandma's gonna be using this and she doesn't know the difference between like, you know, optimistic rollups or ZK rollups. She just wants to like, I mean maybe in like a far future or whatever, she just wants to send her kids like 10 ETH or whatever. Like it doesn't matter. It's a lot, yeah, but like, you know, she did very well. I don't know, yeah. She invested in Dogecoin or whatever. But like, you know, when your browser is using HTTPS, like as an end user, it's like, I see no difference. Like the only thing that happens sometimes is like some website certificate is like out of date, and then like I get annoyed and I just have to click a bunch of like open this page, whatever, I don't care kind of buttons. But like, you know, that's the only cost that I have to pay as a user for that security. And like, yeah, privacy is a hard sell because like, I think at this point privacy like has those extra hurdles that the end user has to go through to use. And I mean, I'm not like able to answer any questions, but like I think we need to find a way of like getting those hurdles a little bit smaller for the end user, because otherwise they're not going to use it.
Yeah, I mean, I think that's even true for crypto native people. Like, if you're like for Alio and for other privacy networks, they usually have some sort of UTXO model baked in for the privacy part of things. And so that requires you to scan the entire chain history to find your notes, to even know what your private balance is, which could take a really long time.
Yeah.
And bandwidth and, you know, whatever. And like what I was talking about earlier with proving, so like, I think even for crypto native people, like jumping to a privacy wallet, they're like, what is synchronization? Like, where's my balance? You know what I mean? Or like, and so like we've been doing a lot of interesting work there, trying to speed that up or make it more seamless. But like, that's even just for crypto native people. It's like, if you have to introduce a non-crypto native person to the crypto world and then get them used to wallets and accounts and like, you know, what is an address and what is a wallet and where are there many accounts in here and what's a seed phrase or whatever. And then you have to add on, it's like, okay, well, your private balance is that's done before you can send your money, and oh yes, you can only send like your largest note at one time right now. You know, it's like, yeah, we got a lot of work to do.
Yeah.
I think it's kind of interesting because in the early days of the internet, people were really scared of putting the credit card number online, and so they actually did go through a lot of friction, and they would look for the little like secured by Visa 3E or whatever. And that's like why PayPal took off, because people were really afraid that. So it's like people will go through a lot if they actually care. But it feels like HTTPS is kind of more top down because we techies know like everything should be private, but maybe people don't care that much.
Like, how did people learn what a password was, or like what an email address was?
Yeah.
You know, like mail is just fine. Why do I need email? You know, it's like,
Yeah, I just wanted to add something because it's like the ZK email perspective is going to happen when it's no other solutions. So it's like encryption or maybe like this stuff. So if you say that I'm going to keep your transactions private, it seems that I might not care. But I'd say that if you, for example, if I'm an AM market maker and you say that, oh, this is going to give you the best yield if the pool is like private, so definitely I'm going to use that. Right? So there are some solutions there which needs ZK and there's no other solution. Then you probably will pick up email perspective from there, and then it will spread around like other things as well. Like, you know, we talk about ZKML, there are some stuff that probably come up when like AI agents are going to be like widespread around, so people care like, for example, there was some talk that you want to ask an AI about some medical stuff, and you want to make sure that this AI is an AI which is trained for that. So that's something you use case for like inference. So those are around that probably will happen maybe sooner or later. But
yeah, I think one of the most interesting kind of use cases of that is like, yeah, around proof of provenance. And like Sony partnered with someone, I forget who, but they basically embedded some sort of chip in the camera so that it could kind of take a snapshot of all the metadata of when the photo was taken and where it was taken and all this information. And it could basically like create a proof of that could then be verified everywhere that photo was used. I don't really know exactly how it worked, but that's just like, it's a cool idea.
yeah, I guess Adobe is doing that. So basically, if you change an image, you can prove that this image is from the original. So there's no fake like.
Yeah, I mean, I think identity too in general, being able to prove things about yourself without revealing what those things are, or yeah, like medical data, it's gonna be pretty interesting.
Do you feel like rollups were enough to grow the idea of ZK and start, being funded to investigate more and more? What do you think the next thing that could come around and like be that product that grows the interest might be?
Well, I think it's going to be a multi-L1 world. I think the Gnosis team has been really hard on that for a long time, and like with their Gnosis Pay system that they introduced last July, it's like a 12 component system, but they basically spun up their own L1 for that. And their argument is like if you could claim, if you could fill the Ethereum L1 block space with just ENS claims of like every potential like handle, it would basically take up the next 100 years of block space or something. So yes, I think rollups are really interesting. They've done a lot of good in bringing attention to it and like an intermediate use case. But I think other things like proof of provenance or proof of identity or even other L1 systems that have zero knowledge baked in will also do a lot to accelerate it.
Because it's interesting, the case with the camera is that like you can't apply filters or you can't effectively have misinformation in the news. And that's something that's really compelling, and it doesn't necessarily need to generate like financial value to raise interest in the technology, and then from there you can start to have the time and space to find other product space. Do you think there's something like that, or should it be looking towards crypto and different like ways to solve problems within blockchain.
I do think that like the blockchain space is the most natural place where ZK is going to be. Well, let me start with verifiable computing, which is mostly what I kind of care about and work on. Like, I think that what blockchains are is they're platforms for verifiable computing on the shared state, and now we're just trying to use better like cryptographic tools to basically reduce the cost of doing that. And then you have to wonder sort of, you got at this in your presentation, like we have technology where, like when does it make sense to apply it? And this is a pretty expensive technology to use, so I think it's basically will be applied for high value transactions and like basically monetary use cases or use cases around transmitting a lot of value, because that's where you actually care to use something that is kind of expensive to use or resource constrained, but it gives you security guarantees that you need. So yeah, basically I think it will be a blockchain use case, whether it's rollups or I also think interoperability solutions like ZK bridges or another kind of major thing that actually just improves kind of user experience. But this is going to have to take off to drive down the cost of ZK and verifiable computing to the point where it can start to be used in like ML or other applications.
Well, this kind of feels like a numbers game where like it's kind of modular, that like I'll take 1,000 times as much time verifying or proving something if I can like extract this very concrete value out of this system that like has numbers involved, like numbers attributed to the computation that I'm doing in gas, versus problems that might uniquely be solved by this sort of primitive. So maybe that's the question also. But
Sorry, I didn't quite follow that.
the end part. So like, there's clear risk reward in blockchain world of I take X more time to do this thing and I get like Y more value, and when that's worth it, I should use this as opposed to like optimism, etc. Versus in privacy scenarios, maybe there's some clear thing that this solves that no alternative really solves, and it's not about just some number that you could put to it. It's like this becomes compelling because it's doing something unique. But I don't know what that looks like, or I would be sprinting towards it. So
I mean, I think like there's I don't know any. Well, I have some examples in my head, but like even just traditional finance using ZK, like like for example, when you apply to rent an apartment in New York City, you have to like give them 2 years of bank statements and social security, everything, right? And like sometimes it's really sketchy, right? Like you email someone that you met for 15 seconds when they show you the apartment, and now they suddenly know everything about you. Like who's to say they're not scamming you, all that kind of stuff. Like there's got to be a better way, right? Or like, for example, like I just went through a process where I bought a house, and they looked through every single transaction of my bank account for the last 2 years, and they would email me, what is this $200? Where did this $300 come from? And I'm like, that felt like a massive violation of privacy. And it was kind of like a radicalizing moment for me, where I was like, there's gotta be a better way, basically. And like, I mean, I don't know what it looks like, but I think like as a good, maybe like the future where like blockchain is everything is like pretty far out, but like there may be stepping stones along the way, and I think one of those stepping stones is like introducing some of this like zero knowledge or like blockchain type ideas into traditional finance, so that we have more privacy, we have like things that we take for granted in blockchain, like in traditional finance.
Yeah, I think I met a guy like CK6, I don't know, 2 years ago in Amsterdam, and he was working on a project that was like a VAT tax fraud ZK system where like, I don't know the specifics of VAT but I think more crucially, it's actually more efficient for the government to be able to not have to do as much work on their end. So I think like also just increasing efficiency on the verification side is huge. But I think that the other interesting thing is like, okay, well, if you're applying to an apartment or applying to buy a house, and you just present them with the ZK proof, like, how do we get there?
Yeah.
Like, how do they, if they can
what's
verify
their
it,
motivation to start using the system?
Exactly.
Yeah.
Like, you have to trust where the data came from. You both have to trust where the data came from. And I don't know, it's a very interesting kind of.
You'll need a buy-in from a lot of different parties.
Yeah.
So like where do you get started is like.
Yeah, like where's the most isolated, easy place to get trust buy-in from multiple parties?
Yeah.
I think that's a really interesting question.
Did we have one more question?
So on the sort of matter of trust, one thing I've thought about a couple of times here is that there's sort of, when you look at these proof systems, there's sort of two different levels of trust. One is trusting that the mathematical protocol they're trying to do is actually valid. And the second is trusting that the code is bug free. And I sort of wonder, I sort of work with Eli on Porky 3, we've definitely found bugs that we've fixed sort of down the pipeline, but I do always wonder, at what point can you have some sort of confidence that you actually have a proof system that works?
How can I trust that the front end that's showing me the proof verification result is showing me the correct verification result?
That too, right?
How can I trust that GitHub is storing the correct code?
Yeah.
Right? Like, how can I trust that the ISP I'm using is not giving me bogus data? Yeah. Like, you have to trust something at some point, right?
Or there's trade-offs.
I guess to add one thing that I've been thinking about is I do think that the end state of these proof systems should software-wise decouple the verifier logic from prover logic. So the prover logic is extremely complicated, but actually has, in the case of verifiable computing and non-zero knowledge, zero security implications. Like if the prover can produce a proof, the verifier accepts it, they should accept it. So I mean, while we're developing this code base, I do imagine that in a more mature state, we will pull the verifier out into code that is optimized to be simple and not performant, and that can be audited independently, and then the prover is just going to be some like complicated hairball that involves hardware and software components.
I mean, I think like a prime place for like formal verification as well, where you can like use like a very concrete, maybe not super performing, but like formally verified implementation of these kinds of things. And then who do you have to trust? You have to trust like the kernel or the type checker or whatever. And so you have to trust someone, but like these people don't have financial motivation to like fake, or maybe they do, but I think like formal verification, like verifying the verifier basically is. And there was a paper like just a few days ago about this. It's on the archive. Yeah.
Well, we're about at time, so I wanted to wrap this up, but thank you all so much for coming. To the audience as well. ZK Hack is a great place to learn more about ZK. I'll be emailing out, I guess, slides and maybe videos from this. This place is Fractal. Feel free to meet any of these wonderful folks and talk too. Thanks.
Thanks.
Thank you. Thanks for organizing.
Yeah.
No one might get it for charge.
That was it. Yeah, it was a good one.
Oh, I think it's like verifying the verification. Let me look it up. It was
Just,
no.